This is part 3 of section 5.6. We are dividing fractions. So what we're doing here is we need to make sure that all of our terms are there and that they're in the right order. I have a square, a first power constant, it's in the right order, nothing was skipped over. A first power and a constant in the bottom, also good. Okay, so when we set this up, it's p plus 6. And then give yourself space here as you go along. And we're going to go through exactly the same process we just went through. Okay? I want to concentrate on the p and the p squared. What do I have to multiply a p by to get to p squared? Another p. So I'm going to put the p up here. And now you take this and you distribute it. P times p is p squared. P times 6 plus 6p. Now we are subtracting. Okay. And then what should happen is our first term should cancel out. And then we have 2p minus 6p is going to be negative 4p. And then you bring down the plus 20. Okay, now again, we concentrate on our first terms. I want the p to become a negative 4p. So what do I have to multiply it by? A negative 4. So now you do negative 4 times each of these. Negative 4 times p is negative 4p. Negative 4 times 6 is negative 24. We're subtracting, so change your signs. And I mentioned this back when we were subtracting polynomials, but I strongly suggest you do not change a minus to a plus by simply putting a line through it. It can mess you up later when you come back to check your answers. Okay, those cancel, and I get 44 here. There's nothing left to bring down, so my answer is p minus 4 plus 44 over p plus 6. Now I didn't do this on the last problem for some reason, but the way you check this is exactly the way we did with the numbers. I would take p minus 4 times p plus 6, and then I'm going to add 44 to it at the end, and I should end up with this at the end. So let's try this. Let's distribute. P times p is p squared. P times 6 is plus 6p. Negative 4 times p is minus 4p. Minus 4 times 6 would be minus 24 plus 44. If you combine these two, well, you're going to get the p squared plus 2p. Negative 24 plus 44 is plus 20, which is what we have right here. So you can always check your answers by doing that. Okay, so let's try this one. It's definitely bigger. It's not really any more difficult, okay? Well, not much. If you notice in the top that our polynomial is out of order, well, if that's the only problem with it, we just have to write it in order when we set up our problem. But we do need to check to make sure we haven't skipped over anything. I have a third power, a second power, a first power, and a constant. They're all there, they're just out of order. In the bottom, I have a second power, first power, and a constant, and they are in order. So when I set this up, 2m squared minus 3m plus 6 divided into 8m cubed minus 18m squared plus 37m minus 13. And again, when you have a recopying step, you always want to take the extra seconds to make sure you haven't made a stupid mistake, particularly when something should be as easy as rearranging things. Okay, I think I'm good. Now, I have larger polynomials than I did up here. The process is going to be exactly the same. I want this 2m squared to be the same as 8m cubed. To get the 8, I'm going to need to multiply it by a 4. To change the m squared into an m, I need to multiply it by an m. So I need to multiply by 4m. I'm lining up my like terms. Even though it seems much further away, I'm still just lining up my like terms. Now I need to distribute this, and I need to go through all three pieces. 4m times 2m squared is 8m cubed. So this is going to be minus 12m squared plus 24m. Now I'm subtracting, so I change every sign. And then what should happen is our first term should cancel out. And then I add these and I get a negative 6m squared. And it's going to be plus 13m. And then I bring down the minus 13. And we repeat. I want the 2m squared to become a negative 3m squared. The m squareds are already correct, so I need to multiply this by a negative 3. So I put minus 3 up here. Now I take this negative 3 and I distribute it through everything. Negative 3 times 2m squared is going to give me a negative 6m squared plus 9m minus 18. Change every sign and then combine. And your first term cancels as it should. And then we get 4m plus 5. Okay. Now if you notice, there's nothing else to bring down. This whole thing is going to be my remainder. Now one way you can tell that you're done. First of all, if you've been lining up your like terms, chances are you have no more spaces to line things up with. We have nothing left to bring down. But the number one way that you know you are done is to look at the degrees. Now remember, a degree is the largest exponent that appears. Here our degree is 2, here our degree is 1. You are done when your degree here is smaller than your degree here. If this had been a square, I'd have the same degree, I would not be done. But since this power is 1 and this one's 2, I'm done. If you look at the previous problems, we had that as well. Here my largest exponent was 1. Here we would say it's of degree 0 because we don't have a variable on it. And remember, if I put p to the 0 by our properties, that's 1. Okay, so we say this is degree 0, this is degree 1. This is a smaller degree than this one. This was our remainder. This is my remainder here. We need to write our answer as 4m minus 3 plus all of this over all of this. Okay, now this is the kind of situation I was talking about earlier when I said a plus sign is always okay. If this had been a minus 4 right here, I would not have just been able to write a minus here. Since I had just a single term in the top, I could have done this, but since I had a binomial in the top here, I really want to keep the plus sign. Okay? All right, so let's check this one out. 2r cubed minus 6r plus 36 over r minus 3. Okay. Now, one thing I noticed is I have a third power here, but I do not have a second power. Otherwise, they're all in order, right? 3, and then I go down to 1 and 0. They're in descending order. Now, the thing is, I have to have a square term. So what I'm going to do is, and you will do this anytime you have a term skipped over. It doesn't matter if it's skipped in the top or in the bottom. It doesn't matter if you have multiple things being skipped. Every time you have something skipped, you're going to put it back in by doing plus 0 times whichever one you're missing. So 0r squared. We know that 0 times r squared is 0. And so we'd be adding 0, which doesn't change anything. So mathematically, I have not changed the numerator at all. But I really need this spot or things get all messed up. When you set this up, you have r minus 3 divided into 2r cubed plus 0r squared minus 6r minus 36. Okay, this works exactly the same. I want to change this r into a 2r cubed. So I need to multiply this by a 2r squared. So I'm going to put 2r squared right here. Now I take this and I distribute it through each one. So that becomes 2r cubed minus 6r squared. Okay, change your signs. We want to add these together. The first one should cancel out. So I have 6r squared. Now, technically, all I need to do is to bring down the minus 6r. Now, just a tip, one of the things I've learned through the years is that it's very easy to lose part of it. And so I generally just bring down everything. It doesn't hurt. It's not necessary, but it really can help if you just bring everything down every time. You're less likely to lose something. Okay, so repeat. I want this r to become a 6r squared. So I need to multiply it by a 6 and an r. So this is plus 6r. Take the 6r and distribute it. 6r times r is 6r squared. And that's going to be minus 18r. Change the signs. We're going to add these together. Our first term should cancel out. And I get, that's going to be 12r, and then you bring down the minus 36. If we hadn't brought it down here, it would just be one big arrow down, all the way down to here. And now repeat, one more step. R needs to become 12r, so that's plus 12. 12 multiply through here, we get 12r minus 36. So when we change every sign and we add them, what happens? Everything cancels out and we get a nice big 0. So this one doesn't have a remainder. Our answer is right up here.